Welcome back to class. Yes, hope you are learning so far. So in this video, we are going to start learning about resistors. Actually, resistors are a major building block of electronics circuits. So it's important to pay attention. So for example, I have some resistors before me. This is a resistor. See that is a resistor. The autofocus is struggling to pick it up. Okay, this is a resistor. I have smaller ones here. This is a resistor. See how small it is. See, so small. This is a resistor. This is bigger. Resistors actually come in different sizes and shapes. And for the purpose of illustration and drawing, I'm going to be showing you the symbol of resistor. So here you have two symbols. You have a one here that looks like a rectangle, and you have this one that looks like a zigzag line. Where the difference between the two is the issue of standards. So for example, if you are working for an international client or an internationally recognized symbol, this is it. So for the United States, this is their standard. So there's nothing special about that. So let me show you different kinds of resistor you see now. So I'm giving a more clearer image. You see different kinds, they come in different shapes and different so don't worry about that yet. Don't worry about the different kinds of resistor yet, as we're going to be exploring it as we go. So to give it a name to different kind of resistors, they are made from different materials, thereby making their names. So some of them are made from carbon, hence they are called carbon film resistors. Some of them are made from metal film, some of them are made from wires, winding wires together and all. So let me not bore you with that theory. So now what are resistors used for? What do you use resistors for? Basically, they are used to limit current, the amount of current flow in a circuit. Remember the example we gave earlier when we were talking about electricity. So if you've not watched the video on electricity, I want you to go back and watch it so that you can understand what resistors actually do when we talk about current limiting. So that's number one. So number two, they are used as voltage dividers. Okay, this is a little explanation on current limiting resistor. And you see here that this is a battery source. The resistor is connected in line, or technically speaking, if an electrical person is speaking to you, it will tell you in series. So when you say something is in series, it's just connected in the same line as it is now. So you see this LED bulb, it's called light emitting diode. You find it in most electronics to give indication. They come in different colors. They come in red, yellow, blue, orange, white. So they come in different colors. So you see resistors together like it, with it like this. Why? Because this light emitting diode cannot take the entire 9 volts that is coming. If you find any of those bulbs and you connect it straight to a 9-volt battery, you will blow it up. So in order to avoid that blowout, you connect a resistor in line or in series with it. I'm going to show you how to calculate the value of that resistance when we get to that point. Another use for resistor is voltage division. So now this is a voltage divider, and this is a simple circuit diagram. You see the battery, from the positive of the battery goes to this resistor, then goes to this other resistor and goes back to the negative. Albeit, we now tapped out from in between these two resistors. So the first resistor, we call it R1. Just follow me, right? Just follow me. The first resistor, we call it R1. The second resistor, we call it R2. Just follow me. And the input of the battery voltage, we call it V in. And the output of the voltage that will be in between these two resistors, we call it V out, right? So we're going to do a little bit of calculation. In my next slide, I already gave the formula and all, but I need to make this more interactive. let me just explain the formula. So just look at this formula. There's a way it is derived. I won't take you through all that theory. I just want you to understand this voltage divider principle because we are going to be using it a lot in reading voltage signals from sensors as we go forward. Alright, so the output voltage that you will see here, the output voltage here, is equal to R2, that is the value of this, divided by the value of this plus this, multiplied by the input voltage. Let me come again. The output voltage that will be between here, in between the two resistors, between here and here, is equal to the value of this, which is R2, divided by the sum of the value of this, which is R1, plus R2, multiplied by the input voltage. So for example, if the input voltage is 9 volts, are you following? And R1 is 1000 ohms, that is, this one is 1000 ohms. And R2 is 4700 ohms. That is, this one is 1700 ohms. What will be the output voltage? Just slot in the formula. So V has to be equal to 4700 over 1000, which is R1, plus 4700, which is R2, multiplied by the input voltage, which is 9 volts. So by the time you do the sum on the calculation, you will get 7.42 volts, right? So you get that voltage. If you don't understand, you can just refer back to this screen, or you can ask questions on our Telegram page, or you can drop your question in the comments and ask question. So now this is it. This is it in the basic form. I'm going to draw this same circuit in our simulation to see if our circuit is actually correct or not. So let's head back. So let me show you how this works in the simulation. So as you can see, this circuit is already drawn here in the simulation. And don't forget that our R1 from our conversation, our R1 is 1000, our R2 is 4700. So let's head back now into the simulation and see how this works. So first, so as you can understand how to actually draw this circuit in your simulation too, I'm going to delete everything that we have here. I'm going to delete everything. Delete, 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 delete. So first, let's bring in our battery. So don't forget, this is where you can pick your components from. So you can see 9 volt battery here. So I'm going to select 9 volt battery. So I will drag it into this space. So now we've brought in 9 volt battery. I would like to rotate it. So this is rotate icon. So I'm rotating it now. Once I'm done rotating, I can bring it further inside. So that is done. Then I need 2 resistors. So this is my first resistor. Then this is my second resistor. Their values, the value of R1, don't forget, which is this our R1, is 1000 ohms. So I'm going to set it as 1000 ohms or 1 kilo ohms. Kilo means times 1000. So when I say 1 kilo ohms, it means 1 times 1000 ohms, which is equal to 1000. Do you get that? We're going to be using this a lot of these prefixes in our explanation. So 1 kilo ohms. The R2 is 4.7 or 4700 kilo ohms. 4700 ohms or 4.7 kilo ohms. So we're going to leave it like that. So let's draw the circuits now. Let's draw. Don't worry, be free to practice. Now to draw a corner, just get to that point and left click. So once you see the red dot on the component, it means that you can left click or click on that spot if you are using your phone to connect those join two points together. So we are going to connect this point together too. Are you following? So left click or tap, then tap. So it's connected. You see this point a little bit slant. I love my diagram to be neat. So So I will adjust it and make it straight. Now the beautiful thing about this software, you can change the color of each connection to make it more visible, more friendly, and more understandable. So by default, black is for negative, red is for positive, and you can choose any color here for your in between. So the next thing that we want to add is a meter, a multimeter to show us the voltage. Do you understand? So I'm going to come here and search for meter. So once I search, I saw this multimeter. That's what I'm looking for. I'm going to drag it into my screen. Now I have it. So you can see the positive and you can see the negative. So the positive goes to in between this junction, and negative goes back all the way to the negative. Do you know why it's using red color? That's because it is red that is selected here. So let me change the negative back to black, and let me change this one back to green. Alright, so don't forget the voltage between here and here is the output voltage, here and here is our Vin. So when we did our calculation, we calculated that the output voltage will be 7.42 volts, provided that the resistances are 1000 ohms and 4700 ohms for a battery voltage of 9 volts. So now let's run the simulation and see if this is actually correct. So to run the simulation, we are going to click on Start Simulation. Start. Do you see that? So the meter is reading 7.42. Beautiful. You've done that correctly. So that is a simple voltage divider. Now let's go on to resistor color code. How do you know the value of a resistor? I showed you different resistors the other time. I showed you this resistor. They have a particular color on them. I just wish my camera is able to pick them up. I show you this. This is very small. The camera may not be able to pick it at all. So how do you know the value of a resistor? Resistors are color coded. You hear what I said? Resistors are color coded. So first, you can examine your resistor closely. You will discover that most of them has at least 4 rings of color around them. Some have 5 rings, and I've seen some that also has just 3 rings. So these rings and their color determine the value of the resistor. It determines the resistance of the resistor. So this table here is to guide us. So let's say, for example, anywhere you see black, so it's divided into first band, second band, third band. Now actually in large resistors like this one here, you will see that, let me try, good, that's beautiful. You will see that there's brown, there's black, there's a faint gold here, and there's a far color at the other end. So, but in very small resistors like this one, you may not notice that the distance may not be that large for you to pinpoint which one is a color that is at the far end. So I created an assumption when I'm reading the value of resistance. So this is what I do. So I look at if it's a small resistor and it is 4 band. Most 4 band resistor, their last color is gold. If they are 4 band, gold, or at best silver, but most of the time their last color is gold. If they are 5 band resistor, some of the time their last color can be brown or red for 5 band resistor. So enough of the theory, I'm just giving you codes here. So let's actually read a resistor value. So this particular resistor in this image has the first band to be green, the second band to be blue, the third band to be yellow, and the last band to be gold. So what is the value of this resistor? You can screenshot this part, or you can always refer back to this table. But if you can cram this notation. Just say big, beautiful roses occupy your garden, but violets grow wide, so get some. Big, beautiful roses occupy your garden, but violets grow wide, so get some. Big stands for black, beautiful stands for brown, roses stands for red, occupy stands for orange, yours stands for yellow, garden stands for green, but stands for blue, violet stands for violet, grow stands for grey, wide and so stands for white, get stands for gold, some stands for silver. So from black, so if the value for black is 0, 1, brown for 1, red for 2, orange for 3, like that till white. So you get to number 9. Do you get? So let's do something practical. Let me go to the next. Right. So you have this resistor, for example. The first color is brown, the second color is red, the third color is black, and the last color is gold, just like I said earlier. Most 4-band resistors, their last color is gold. So the first band, which is brown, what is the value for brown? 1. Look at it. The value for brown is 1. So you write down 1. Write down 1. The second band is red. What is the value for red? The value for red is 2. Do you get? So you write down 2. So you already have 1, 2, which is equal to, we put it together as 12. Now the third band is called the multiplier band. Do you get that? Let me say that again. For a 4-band resistor, the third band is the multiplier band. That is whatever the color of the third band is. So for example, the third band here is black. So we go now to go and check under multiplier. What do we multiply it with? If it were black, it is multiplied by 1. Do you get that? Multiply by 1. So once you do that, you see here multiply by 1. So the resistance of this resistor is 12 multiplied by 1, which is 12 ohms. Simple. 12 ohms. Now the last band here, which is the fourth band, is the tolerance. Now there is a trick here. How do you recognize a faulty resistor? Maybe you are testing a circuit and it's not working well, and you sense that maybe one resistor is actually bad, but it doesn't look like it's bad, it's not burnt. So if the resistance is still within the range of its tolerance, this tolerance means that you don't expect this resistor to be exactly 12 ohms, but it is still correct. The resistor is still in good shape as long as the value fall between 5% of 12 ohms. So if you do your calculation, 5% of 12 ohms should be around 0.6, 0.6 if I'm correct. 10% should be 1.2. 5% should be 0.6. So you expect that the value of this resistor under normal condition should be between 12 minus 0.6, that should be 11.4 plus 11.4 to 12.6. So if you measure it with your multimeter and the value still fall between 11.4 and 12.6 for this particular resistor that has this color gap band, the resistor is in good shape. You get that? So I just dropped that for you to understand. So the color of the resistor, the last band, determines the tolerance of that resistor. So for this one, which is gold, it is plus or minus 5%. Let's go on. I have another resistor here. So this is a 5-band resistor. Look at it. So the first color is orange, the second color is orange, the third color is white, the fourth color will now be the multiplier, and that color is black, and the last color will now be the tolerance. Remember I told you earlier that in most 5-band resistor, the last color is always, most of the times, brown. Most of the times brown. Now 5-band resistors are precision resistor. So I will explain. So let's do for this resistor for example. So the first color is orange, big, beautiful, roses, occupy. So 0, 1, 2, 3. So that is 3. Second color is also orange, another 3. The third color is white. Let's count. Big, beautiful, roses, occupy your garden, but violet grow wide, which is white. So if I count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9. So you have 339. The multiplier color is black, that is times 1. Or if you don't get it for the multiplier, so that you won't have to go back to always go back to your table, I advise you always do that until you master it. But let me give you a cheat code. So the multiplier, you remember the colors are 0, 1 like that. So the multiplier will be 10 raised to power the value of the band. So for black, you know the value of black is 0. Black is 0. Big, beautiful. Black is 0. So it will be 10 raised to 0. And 10 raised to 0 is 1. So that's the cheat code around there. So by the time you do the multiplication, it will be 339 multiplied by 1, which is also 339 ohms. Albeit the tolerance value is brown, and the tolerance value for brown is 1%. Compare it to the last 5%. So let's assume for 1%, 1% of 339 should be 3.3. 3.3. So that means you expect that the resistance of this resistor should fall between 336 point something to 300 and sorry about that, 341 point something. If it were to be 5%, you'll be looking at almost 10 ohms difference. So the resistance can fall between 329 to between 345, which is a wider range. So when you are dealing with maybe precision measurements, you want to measure the exact voltage in your project, you want to do things like voltage measurement, you want to sense what is going through, and you need precision, go for precision resistors. So we've talked about color codes, and let's talk about resistors in series and in parallel. I think I'm going to do this in the next video. Drop your questions and let me know what you think. Thank you.